as well as the IVO project. One of my interests in terms of looking at computer-mediated communication is how we communicate with technology as well. So how we communicate with speech, with systems through speech. If we think about artificial partners, for instance, like your Amazon Echoes or your robots or things like that, how do we engage in dialogue with these new forms of partners? And what does that tell us about dialogue with those partners and how we can learn about dialogue more generally from those interactions? So that's what the talk is going to be about today. So it's a slightly different angle from some of the stuff that we do in the IVO network, but it's some of the aspects that we also do here at UCD, and I hope will be of interest to you. So I was going to have an introductory slides, but I think Chris done a really great job in terms of introducing me. So thanks very much for that, Chris, as well. So one of the things that I would just say here is that most of my work looks to try and combine my interests in cognitive and experimental psychology, in particular aspects of psycholinguistics, with human-computer interaction, whether that's computer-mediated communications through Zoom or video conferencing, all the way through to interacting with automated partners, which would see things like kind of robots or things like speech interfaces and speech systems. In particular, speech interfaces is one of my main interests. Of course, all of this work that I'm going to present today doesn't happen in a vacuum. So there are a number of really great people who collaborate with me and I collaborate with, who've informed the work and inform all the work that we do at HCI UCD. So we have a very tight-knit team, and we all work on the research that we conduct. And so particularly today, I'll be focusing on collaborations that I've conducted with Phil Doyle, as well as with Paula Pena. But everybody has been involved in these, including Orla, Dan, Lee, Yunhan, Diego, Justin, and Anna. And if you're really interested in what we do as well, please go and look up these amazing academics who are either postdocs or PhDs within our lab, and that they're starting within these areas. So please go and look them up and look at their amazing work that they're doing too. So my research focuses very much on this idea of how we communicate with speech devices. So how we communicate with, as I said, artificial partners. As you may have noticed, these artificial partners that we communicate with have kind of balloons in terms of the devices that we see either around the home or being marketed to us. For instance, I think the Super Bowl now has an Amazon Echo ad every single year, and it's one of the highlights of that event. But these devices have made their way into our homes, as well as made their way into a number of different contexts. And so that means that we have this new form of dialogue partner that we interact with regularly. And the question is, how do we interact with these devices, and how does that compare to human-human dialogue? So that's some of the major questions we look at in UCD. And that's because one of the places where I kind of started work and where I kind of still find fascinating is this type of interaction, the interaction between two people. So what happens within this dialogue, and how we can then use that understanding to be able to interpret what happens with these devices. So generally what we see in human dialogue that is of interest in our research is this idea of kind of building common ground, identifying elements of shared context and shared knowledge, but also the fact that we're very quick at making assumptions about partner capabilities and partner knowledge whenever interacting with others. And when we go through this, we make a number of assumptions, whether it's based on stereotypes or based on some other elements of heuristics or cues. And then this gets shaped and formed as we interact with other people. So Susan Brennan calls this global and local partner models, this idea that we have this global stereotypical view of what an individual might know and understand based on some of the cues they give, for instance, accent or social status or some elements like this. And then that gets whittled down and turned into a kind of an individual view of what that person might know and understand, and what we then might share in terms of knowledge that we can then utilize in conversation. And so what we look at, amongst other things, at UCD is we want to understand how these perceptions are made with speech interfaces. In particular, the speech interfaces that you see every day, but also more widely with human-machine dialogue partners. And then also how that influences language production or user behavior in interaction. We're really interested in not only the fact of what people perceive about system competence as dialogue partners, but actually whether that influences language production at all. And I'll be showing you a bit of evidence that we have from some experiments that we run to identify how this might operate in interaction. So first question, I suppose, would be, well, what are these partner models? So, and this hinges on Dr. Phil Doyle's PhD work that's looked at how people perceive speech systems as conversational partners. And the definition from Phil's thesis, which was published in Chi a couple of years ago, is this idea that it's an individual's interlocutor's cognitive representation of their beliefs about a dialogue partner's communicative capabilities. And as I said before, relating back to Susan Brennan's work on this idea of global and local models, this might be developed by previous experience with a similar device or previous experience with this category of devices, as well as assumptions and stereotypes about what these systems are good or bad at. And then these might be dynamically updated based on the behavior or the events that occur during dialogue. And so we've gone through a number of experiments, especially in terms of Phil's PhD. If you're interested in this topic, I'd really, really recommend that you take a look at that PhD. It has a huge number of detail and a number of studies. They have looked at this idea about what happens when things occur in dialogue with these models, as well as what these models actually structure and actually are. And I'm going to talk a bit about that in a second. So one of the things that we discovered through some of this work is that these partner models, these models that we have of a partner's capability and ability as a dialogue partner when we're interacting, these for speech systems, are generally multidimensional. They're not just this kind of individual blob that we have about our perceptions of capabilities. They have a number of dimensions linked to them. Now, to understand these dimensions and to get a sense of what really fuels our perceptions of partner competence and capability with machines when we're interacting with human-machine dialogue, we conducted a number of studies and then a principal component analysis to identify how the data that we gathered from these studies clustered around particular themes and topics. So the first study that we ran here was called a repertory grid study. And this is where we got 21 users of speech interfaces to come and take part in an experiment, which I'll talk a little bit about in a second. We got them to interact with either a speech agent through a smart speaker, a speech agent through a mobile phone, or another human partner. So we had these three different dialogue partners that we asked people to interact with. Now, in the method, in the repertory grid technique, what you do is you have two examples of things you want people to compare that are similar, and then one that is different. Hence, we have two speech agents and one human partner here. What we then did is we gave them 9 questions or 9 kind of topic starters to be able to kind of conduct conversations or to conduct a dialogue with these dialogue partners. And these involve things that systems were good at or that humans were good at. So, for instance, some of them might be more social, opinion-oriented questions. So, what's your favorite music? What do you think of insert famous individual? Or things that a system might be better at, but humans might not be so good at in dialogue. So things like recall of numbers or recall of particular information or events. So we asked people to interact with these partners. And then what we got there is we asked them to give us a list of terms, a list of words that explains the similarities and differences that they felt that existed between these partners. And so this is what the technique usually uses whenever being used it's mostly used in clinical psychology. And what we have is a list of words that people use to describe the partners that they've described. We then ask them to create antonyms to those. Then it gives us almost like a semantic differential scale to be able to get a sense of what dimensions are important to users whenever thinking about speech systems as communicative partners in comparison to human dialogue partners. So out of this, we got 246 word pairs out of the participants, and then we took a second phase to this to look at, well, actually there are measures in psychology research that look at similar concepts like partner models. So things like theory of minds research. So we looked at some of the surveys that were available around that, and we took some of the word pair items from those surveys, or made word pair items based on the items that were included within that, to create a bank of word pairs that people use to describe partner competence whenever thinking about dialogue capabilities. Then we went through a stage of word pool reduction, which led to initial screening by 3 independent experts of speech interfaces that looked at identifying, well, we gave them a definition of the partner models that I've given to you in this talk, and then we asked them, well, can you identify the items that are pertinent to that? And then these were kept. So there are 127 word pairs after that. 151 word pairs after the domain expert screening. The step before was an initial screening for duplicates and for elements of for things like that whittled down the word pairs to 127 words. The key study then here was that an online study that we asked people to think about the interactions that they've had with speech interfaces like Google Alexa or Apple Siri, and to rate those interactions using these polls. So thinking about the systems as dialogue partners. So think about the dialogues that they had, the competence and capability that people felt those systems had. Now, this had allowed us to do principal component analysis on the scores that were gathered to see how these clustered together. And what we then see whenever we run that principal component analysis was that there are 3 key dimensions to people's partner models. So 3 key clusters within these word pairs that were generated. And these focus on things like competence and dependability. So whether people felt that the information that the system had was particularly relevant, whether they were competent, whether they were dependable in terms of the interaction. And so the second key dimension was this element of human likeness. How alike were the systems to human partners in their capabilities? So it might be that there are particular capabilities that are noted here, such as like empathy, or things of just category differences, being human versus machine. And we find this in research when we look at human-machine dialogue, is that people very commonly make a category distinction when it comes to humans as dialogue partners and machines as dialogue partners. And they have stereotypes around what each can and can't do. And these items were the ones that were captured within this human likeness components. We then have this element of cognitive flexibility. How flexible is the system in terms of adaptation or adaptability to particular aspects? What traits do they have when it comes to that element of cognitive capability and flexibility? So here's the list of the items that we see and the factors that we have, and you can get these accessed in the paper that was published at CHI in 2021, and we can see that there's a sense of clear category difference in the human likeness conditions. So there seems to be in these partner models, people are making a category difference, whether something's a human-like or machine-like, and in some cases, whether it's lifelike or tool-like. So whether it should be taking the role of a tool or should be taking the role of a lifelike individual whenever interacting. Then we also have the traits that are related to things like machine-like and human-like, things like authentic or fake, social or transactional, which in previous literature has been found to be related to this category distinction about the role that systems have in dialogue compared to the role that humans can take in dialogue. This idea of partner competence capability has this element of whether it's reliable, whether it's ambiguous or clear, whether the dialogue is meandering or direct. And then when it comes to this idea of cognitive flexibility, it's whether the system can be interpretive or literal, or whether it can be spontaneous, or whether the dialogue is completely predetermined. And so we have these dimensions that people seem to be making distinctions on whenever we're thinking about systems and human partners. So what might influence these partner models? So we know that there's maybe these 3 layers to this onion of a partner model, this perception of competence and capability, and it might have 3 different dimensions. By the way, in this case here, we don't make any causal distinctions between these dimensions. So the principal component analysis doesn't allow us to make those causal relations between how these factors relate. We get correlations about how these factors relate, but it may be the element of human likeness might influence scores on partner competence and dependability, or perceptions of competence and capability. So there may be relationships within these factors that we see in interaction. And that's an important thing for future work to be looking at, and we're looking at that at the moment. And this relates to one of the questions about, well, what might actually influence these perceptions? What might influence the particular dimensions that we see, or people's evaluations of those dimensions in interaction? So we conducted some work in 2017 that looked at gathering focus groups to understand what people's experiences were with intelligent personal assistants, so things like Siri or Google Alexa. And we wanted to understand what were the barriers and what were the challenges in this interaction, but how do people perceive them as dialogue partners? So what are the things that might be cueing some elements of those perceptions, those understandings that we need to know when we're interacting with a system, those that might be giving us some element of heuristics that we might need to use in interaction. So in this study, what we did was that we gave participants tasks beforehand to conduct, so that they were and these were infrequent users. That's the general type of user interaction patterns that you see in speech interface interaction. Nobody is really a power user of these systems. It's not that I say nobody, but very few. There's quite a low percentage. A significant percentage of people are kind of dabble with these systems. They might use them every now and again. And so because of that, we gave them tasks to do so that they could focus on those tasks in the focus group. We then conducted inductive thematic analysis on those focus group transcripts, and we identified 6 key themes. Now I'm going to focus on 2 of them that may influence partner models, but we had a number of others. So things like trust and privacy with these devices, issues with poor integration with preferred applications. That's been changed since, and also elements of public embarrassment whenever using these. So being on the bus, for instance, and like kind of and using these systems was seen as kind of an embarrassing thing to do. But these 2 key elements here were this aspect, especially for partner models and how they might influence, what might influence partner models, is this idea of a human-like nature of intelligent personal assistants. So people noted that the design of these systems is almost human-like by default. So we use human-like voices in these interactions. They speak like humans. They use very human-like language. They try and use elements of prosody or elements of trying to incorporate things like basically kind of dialogue disfluencies whenever interacting, especially in terms of future systems. And so designers are trying to make them seem very human-like. And that's clearly going to have an impact on some of those dimensions of partner models we see, the perceptions of flexibility, the perceptions of human likeness, but also the perceptions of competence. So there's some work recently that looks at this idea that people feel that if it's more human-like as a design, there may be a problem in terms of the fact that we presume human-like capabilities, or some elements of capabilities that are more human-like with a speech system. But those systems are nowhere near that at present. All they can deal with is very simple adjacency pair dialogues. So and also very kind of command response dialogues. Nothing really more complex than that. Some follow-ups at some points, but it's very, very, very primitive in terms of how they deal with dialogues. So we then got an element of speech recognition performance, people highlighting that when there were speech recognition errors, which happen often, there's an issue where people perceive the system as not being able to be functionally trustworthy. So there's a sense that the performance might actually have an impact on how capable people feel these systems are as dialogue partners. So based on this, we tried to identify, we did some work to try and look at, well, what are the particular aspects of design that could be influencing things like lexical choice in interaction, or things that we know might be sensitive to partner models. So literature in psycholinguistics highlights that we conduct audience design to try and design our utterances to our partners, right? And so we also call that recipient design in conversation analysis literature. And it's this sense that we're trying to estimate what a partner might know and understand and changing our language accordingly. And one of the things that's been highlighted in literature around human-machine dialogue is that there's adaptability around lexical choice. There's adaptability where people change the words they use, or they also change the grammatical structure of what they say to systems to try and guarantee communication success. So Sharon Oviac calls this a kind of an issue of where systems are constantly seen as at-risk dialogue partners. They're seen as partners that we have to adapt to rather than ones that adapt with us in interaction. And so one of the things we wanted to see is that, well, are people using the design of these systems potentially as a cue to inform audience design, to inform this element that people are changing the particular language that they use. And we focused on a particular lexical choice study using similar methods from psycholinguistics to explore some of this. So basically, the idea behind this experiment is that we sometimes come to interactions with some baggage. Now you see what I did there. So what we do is that in this case here, we might use heuristics from human-human interaction to inform what we do in human-machine dialogue. And this is something that has been seen throughout literature and human-computer interaction. So Cliff Nass made a career on this idea of thinking about what's called computers as social actors, where people make a distinction about the systems not being, they're not humans, of course, but they use cues or social heuristics to be able to guide what is appropriate or what they do in interaction and dialogue. And so this is where this experiment is informed by. Do we use elements of the design to influence these types of to influence our language choices, if our language choices are pertinent to the design that's being chosen for the system? I'm going to give you an example of this just now. So, for instance, this is coriander. I know it's getting close to lunchtime, so my belly just rumbled there. So we have coriander here, but we can also call, in American English, we can call that cilantro, right? So there are two lexical alternatives that we can choose between this item. So I might be interacting with Michael D. Higgins in my local Aldi, so our president here in Ireland, and I might say, Michael D, could you pass me the, if I was going to do audience design, I might say, could you pass me the coriander, right? I'm taking into consideration that he's maybe more likely to understand the term coriander than he is to understand cilantro. He might understand cilantro as well, but it might just take him a little bit longer. So for efficiency of interaction, we might use, I might use coriander. If I was interacting with Elizabeth Warren, for instance, then I might use a different term. So if Elizabeth and I are shopping in Aldi, along with Biggledy as well, then we might say, look, can you pass me the cilantro? So there I'd be doing audience design. I'd be choosing the words based on what I feel would be more accommodating to the partner that I'm interacting with. And this is the premise for the experiment that I'm about to present. It's this idea, do we do this with systems? And do we do this based on the design of systems? So what we do here is in the first stage, we give a familiarization session to the participants. So this is to get them familiarized with the particular choices of terms, whether the American English or Hiberno English terms that were being utilized. And so in this case here, we gave them 18 pictures with Irish or US English terms and told them they were asked, they would need to memorize these, and they're going to be asked to name all of those after the game. And this is a common trick that's done in social psychology work, where you need to prime people with some of the content before they go into the experiment, or you need to them to have some form of information before going into the experiment. And this ensured that people had the choice at hand if to do so, because otherwise it might be that people aren't making the choice because they don't necessarily know the lexical alternatives. So then stage 2, we did a referential communication task, which are commonly used in psycholinguistics to look at lexical choices. And what happens in these tasks is that the participant and a partner take turns to be a matcher and a namer of particular objects. And in this case, the partner was either a computer or a simulated human, which was either had a US accent or an Irish accent. And this is similar to the method that's used in Brannigan et al. In 2011 to look at things like lexical alignment and lexical accommodation and interaction. So to give you a better idea of the experiment, the screen looks like this. It's really not very fancy at all. And the top screen would be, if you were the matcher and you're a participant, you'd see these two images, so the image of a duck and the image of a book. And the participant in this case would hear their partner utter something. So it would be, it's the book. Now, the aim of the partner in this case is the aim of the participant in this case is to select the image of the book as quickly and as accurately as possible. Then after they've done that, the screen moves on to the bottom screen here, which is the namer screen. Now, at this point, the participant is meant to name an image. So they'll see a red box around an image. Now, this has two lexical alternatives, depending on whether you want to use the American lexical alternative, which is the wrench, or the Hiberno English lexical alternative, which is the spanner. And so you have these two alternatives that we can utilize. And so what what we're measuring here is which word people are going to be using whenever describing these images. And there are 18 different images that we used that had these lexical alternatives. So we're looking to see on overall what's the likelihood of people using these lexical alternatives. So I was going to play the audio here, but I might have to come out of the slides, and so I don't want to do that, because I've been told that Teams might be a little bit tricky with that. But if anyone wants to listen to this, you can go to the Sarah Voice website to see Sarah Voice Caitlin and Sarah Voice Hannah as the accented speech that we use for the machine conditions. And you can hear that these are very, very natural voices that are being utilized. I might try and give it a go just for a second to see if the embedded ones will play, but they may not. So if you heard that, then you'll hear that that's a very kind of Irish accented speech synthesis. Now, these are all automated. This is all automated speech that's being produced here, with the speech signal being using what's called text to speech to be able to do this. And then there's the which is the US speech, which has a US accented voice within that there. So what we found was that with the US partners, that we saw that there was an increased percentage likelihood, or an increased percentage of the number of times people used American English terms in that condition compared to the Irish condition across the experiment. This happened with the human condition and the computer condition. So it suggests that the audience design components from human dialogue are still generally present in machine dialogue, and people might be making the same cues, so making the same assumptions around the cues. So they may be making assumptions of the capability of the partner based on the cues that we utilize. So in this case, the accents or the nationality of the partner that was communicated to the users. Now notice though that people still used in a majority terms, they still used Hiberno English alternatives whenever interacting with the systems. So although it changes the likelihood of using design-specific terms, there's still a proponent or a propensity to use what's technically easiest for us to use when interacting with a system. So people are more likely to use US lexical terms when interacting with a US system, and that the Hiberno English terms were still the most commonly used. And these were kind of, so there's still some what's called in the field egocentric bias to what we produce lexically in this interaction. And so that's one of the things that we've been trying to look at in some of our studies further on. And I think I'll be mentioning some of those in just at the end of the talk. Another study that we conducted as well was that we wanted to see, well, actually, does it affect what users do in the sense of lexical alignment? Now, lexical alignment is an effect where we use the same lexical term as our partner to try and guarantee communication success, or, so that's audience design explanation, or there may be an explanation where we're actually just doing this because of priming. So there's no sense that we're thinking about capabilities and competence in interaction. We're actually just being primed to use the same words. So we wanted to see whether, well, lexical alignment has been suggested to be audience design driven in human machine dialogue. And Brannigan's work in 2011 looks at this in particular, this idea that the design or the assumption of the capabilities of the partners being basic or advanced influence the levels of lexical alignment that are seen with systems. So we did an experiment here to look at, well, is it the same when we think about design? Rather than telling people that these systems are rubbish versus these systems are really good, does design cue something like this? Does design cue the competence and capability elements that we might see in this interaction, and we might see as being important and therefore linked to lexical alignment, levels of lexical alignment? So we had three conditions in this experiment. We had people interacting with a human, which was me recorded. We then had people interacting with a machine that sounded like it had very robotic synthesis, which used, I think it's a standard Apple voice now, which basically has a very kind of robotic tone to it, which gives it a sense of not being human-like really in any shape or form. And this one might not be able to play actually, but. And so this is, and so it's clearly there's a difference in terms of the anthropomorphic element or the human-like element of that synthesis. But just to check, we asked people to complete measures on sort of a self-report questionnaire looking at assessing elements of competence and capability. Now, this was before our partner modeling work, but some of the items from the partner modeling work are just surreptitiously, not surreptitiously, but just by accident, are also the same type of items that we see in the interaction. So what we see here is that we've got, whenever looking at the scale of basic and advanced, what we see is that, again, there's a clear distinction between people evaluating the synthesis that they hear as robotic, as basic when they hear the robotic voice versus the human and anthropomorphic conditions, and they were statistically significant. Same thing with flexibility. So the robotic partner with a robotic voice was seen as much more as statistically significantly more inflexible than the human and anthropomorphic conditions. And same thing with competence. So there was the robotic voice was seen to be the system being more incompetent, significantly more incompetent than the human and anthropomorphic conditions with those voices. So the system with a robotic voice was seen to be seen as more basic and flexible and more incompetent. So voice seems to have an effect on some of these perceptions, as we've seen in the previous study, the same kind of thing, that they may actually be influencing elements of partner models or the perceptions that people have of speech interfaces. So again, we did a similar study that we did in the previous study, looking at this element of lexical alignment. And again, it's the same thing. It's the matcher versus the matcher and namer screens that we've used. And in this case, the matcher screen, we had the items that we had that we were looking at as experimental items were ones where you could use two lexical alternatives, but you had been primed with a lexical alternative by your partner. And so there's this sense that in the literature that if a partner uses a term, we're more likely to copy that term, again, lexical alignment, consciously through audience design, because we want to try and guarantee communication success. If a system or a human produces it, they're likely to understand it. That's the general premise. So in this case, when the matcher when the participant is the matcher, again, the participant hears something like, it's the coach. So in this case, they'd be selecting the bus image here. Now notice you could use bus for that element, but in this case, the system or the human partner, as it were, used it's the coach. And this is priming with a disfavored term. So this is a disfavored description. So it's unlikely to be used most of the time. Most of the time, people would use bus to describe this. Then in the naming screen, the other image would appear. And we would ask participants to report that item, to name that item for us. Now, what we're looking for is to see whether they use the same term as their partner. So in this case, even though it might be easier for them to use bus as a participant, they may use coach in this situation. And that's because that would be an example of lexical alignment. And so this is what we look at again across 18 items in the game. We have different items with this, and we vary this between favored and disfavored primes as well to get a balance of what people do with favored and disfavored primes. Now, in this experiment, what we saw was that actually, even though the voices change perceptions, they don't seem to statistically significantly change the levels of lexical alignment. The levels of lexical alignment are the differences between these two these colored bars. So in the human condition and the robotic and anthropomorphic condition, we can see the difference between the bars is relatively similar. There may be an uptick in disfavored prime use in the robotic condition, but that can be explained due to noise, especially through the log linear mixed effects models that we utilize to analyze this data. So there seems to be no effect of the partner conditions in this case here, but there is an impact on perceptions. So this suggests that, well, maybe there's some element of partner models driving audience design, but it might be that there's some effects in language that we see that are not driven by audience design and human-machine dialogue. So this goes contrary to some of the literature that we've seen in the past that suggests that audience design is one of the only mechanisms that we see in this interaction. And we show here that actually priming might be involved, especially in lexical alignment in this interaction. Now, just to be sure, we ran this study again and again. So we replicated this study about 2 or 3 times, and the same findings constantly occur. So these are very similar findings as we go on through, and this work is in preparation for a journal article at present. So the question then becomes: is actually audience design driven by partner models the full story that we see here? And some recent work that we're suggesting is that actually it might not be. So there may be a number of different dialogue mechanisms that go on in human-machine dialogue, as the same that happens in human-human dialogue, and they appear in the interactions that we have. So we see that, okay, heuristics can be used at particular points when they're salient, when they're important for the interaction, but sometimes priming might be being utilized. We also see that actually sometimes there may be some egocentric bias in interaction. So we looked at trying to understand, especially in terms of the egocentric bias aspect, whether this actually appears in human-machine dialogue or not. And we just completed the study. So this is in submission and was put in submission a month ago. And in this situation, we're looking at we use a game that's very similar to those used in psycholinguistics, looking at common ground use in interaction. So common and privileged grounds being used in interaction, and how that then influences language production in human-human dialogue. So there's a lot of work by Dale Barr, a lot of work by Sarah Brand-Schmidt that looks at these sort of effects in human-human dialogue, and we wanted to see whether similar effects of egocentrism in language production, or how people use common and privileged grounds in human-machine dialogue interaction, whether it's the same as in human-human dialogue. So the experiment that we see here is that we give a participant a grid of images. And what we're asking them to do is that we're asking them to describe a particular image that's highlighted in a red box again. But as you'll see, there's a lot of distractor images involved in this experiment. And some of them have gray backgrounds, some of them have white backgrounds. The white background images are what participants are told are the items in common ground, so that their partner can see those and themselves can see those. When it comes to the grey images are what's called being in privileged ground. So they're images that only the participant can see, and the partner cannot see. So they're blacked out for the participants. And also in this case here, we've got two images blacked out here for the participant, and they're told that those blacked out images are items that the partner in the interaction can see, but not the participant. And so what we see here is that we see a difference in terms of shared or privileged ground in the interaction. And we want to see whether that has an influence on the language that people are using. So there are three conditions that we had in the experiment across a number of items that we had. So there are a number of different trials, a number of items that we see. But the three conditions that we had for the grounding conditions were the first one, which is basically an example of a grid which is called the one target condition, which is basically that there's only one version of that target that's got a red box around it in image A. And so you'll see there are no other images of bones here. So that means that it's in common ground, but there's no competitor to this image. You'll see in B that there is a competitor to the image, that there are two bones. One of them is a small bone, one of them is a large bone. Now, if you're going to make a distinction about that and you're trying to design to your audience, then you may use the small bone to describe that, because it makes it more specific for the individual, for your partner, to be able to select that image accurately. In C, we see that the two images that appear in B also appear in C, but one of them is in privileged ground. So in one of them, the partner does not have that in their image set, but the participant does. And so what we want to see is actually whether there's differing uses of a scalar modifier. So this idea of using small when describing the bone in this instance, but there are a number of different items as well. We want to see the likelihood of using that in these different conditions. So we would expect that there may be more use of the scalar modifier in the common ground condition than in the privileged ground condition, which is C. But there may also be some interference of that privileged ground. And so we want to see whether people use that privileged and common ground element at all in interaction. And so if we expect audience design, we expect that people will use more scalar modifiers when it comes to when the item has a competitor versus when the competitor is in privileged ground. People should just be using the bare noun of bone in that situation for C. So we had human partners and computer partners in this situation. The human partner sounded like this. So it was a recording of one of the members of the lab, and we recorded them 4 times, and it selected the audio, so it sounded like that the person was doing this online through the system, and that they were coming to each item, kind of new, rather than having the same intonation for all items. And then this is the computer partner. And so there's clear difference in terms of the synthesis that's produced there and the human likeness of that. So just play for those of you there. So what we saw was that in general, we saw the kind of the effects that we would expect to see. So in the common ground condition, people on average use more scalar modifiers than in the privileged ground condition. And we would expect that. That's generally something that we would expect to see in the interaction. That's what we see in human-human dialogue. However, this is different for machines versus humans. And so this is the key consideration here, is that we see that privileged ground, when in privileged ground, people tend to be using scalar modifiers more in the computer partner condition than in the human partner condition when it comes to privileged ground versus the common ground conditions that are generally relatively similar. And this might suggest something to us about what people might be seeing the partner being capable of doing, as well as it potentially people being more egocentric in their language production. Remember, what people see in privileged ground is that they're seeing those 2 images, but they know that one of them can't be seen by their partner. But it might be easier for them to create this small, the utterance, the small bone, because it fits with their information state, which is within that. So we saw there's a difference between the computer and the human. And this might say something about, rather than it being in terms of sense of audience design, it might be actually the elements of the social role that the system has in the particular task that leads us to know whether an aspect of information or an aspect of some of the interaction is more salient to the partner or to the interaction. And we also ran the study again, trying to emphasize this social role of a system more of as a collaborator or as a separate entity than a tool to play the game with. And we actually then saw that the effects were similar with human and computer partners, which suggested that there may be some element to do with people using audience design, depending on the framing of where the system sits in the interaction. So whether it's a separate agent versus whether it's an agent that's involved in the game that has an information oversight, or whether it is seen as a separate entity that's a collaborator versus a tool-like interaction. And we're unpicking some of that in our current research just now. So just to conclude quickly, sorry, that so that partner models, what I'm going through in the talk is that partner models are likely dynamic, system-specific, and multidimensional. And some of the things that we might need to consider in future research about partner models is we need to consider how these models vary by modality, by context, and how they're influenced by design. We've shown that some of these are influenced by design. Some aspects are influenced by design. We've also shown in some work that we're publishing just now that those models are actually impacted by errors in interaction as well. So there is something going on with people's partner models of capabilities in the interaction. And audience design is clearly an important driver of language production, but it's not the only mechanism that's going on. So audience design is occurring. People are conducting audience or recipient design, but it depends on whether it's salient or not to the interaction. So it depends on, it's this idea of monitoring and adjusting that's seen in human-human dialogue, where people might use their partner models, but only when they feel it's appropriate to do so, or when something happens that's signaled in the dialogue and interaction. And so what we're doing at the moment is we're looking at what are the aspects that influence the partner model use in interaction, because we've seen that it's not necessarily used all the time, and that we're currently trying to explore more real-world tasks and more complex interactions to see how these effects manifest themselves in interaction. We've just finished a paper that's been submitted to CHI just now that's looking at cooking, for instance, and how people use grounding and how people use audience design within some of those elements there as well. And so without further ado, I'm just going to thank the sponsors and thank everybody who's funded the work here, the Irish Research Council, ADAPT, Science Foundation Ireland, as well as UCD. And I want to highlight a particular events that we run as well. So this is an ACM sponsored conference that we started in Dublin, but is now in its 4th year, running in Eindhoven in 2023. And if you're interested in research work on conversational user interfaces, whether that goes all the way from chatbots all the way to speech interfaces and robots, then please submit your work here. We have a number of linguists, psycholinguists, as well as human-computer interaction experts, speech technology experts, and chatbot design experts that all come together every year to do that. And that deadline is coming in February. Looking for full papers and short papers and short provocation papers for that. So if you're interested in the work that I presented today and you think, actually, we've got some of that interesting work that we could use as well, and that we might be able to find a venue for that, then think about CUI in 2023. But all that leaves me to say is thanks very much for listening, and I'm really happy to take any questions.